This is CVE 2024-3094, a deliberately placed backdoor in XZ Utils, rated at the maximum CVSS score of 10. This was one of the worst Linux supply chain incidents ever recorded. XZ Utils is a lightweight compression library built into most modern Linux distributions. You don't install it manually, it's included by default. By early 2024, compromised versions had already reached major distributions, including Fedora, Debian Testing, Arch, and OpenSUSE. On the surface, XZ just handles routine tasks like compressing files, logs, and data streams, but compromising a core library like this means compromising everything that depends on it. One of those dependencies was OpenSSH, the foundation of secure remote access for Linux servers worldwide. The backdoor was discovered in March 2024 after a Microsoft engineer noticed unusual CPU usage and SSH login delays on a Debian test system. That small anomaly led to the exposure of one of the most serious supply chain attacks Linux has ever faced. What made this incident different from a typical vulnerability was that it didn't come from the outside, it came from within. The attacker was a maintainer who had been contributing to XZ Utils since 2022. In open source projects, maintainers are trusted contributors, people who can approve changes, publish releases, and directly influence what ends up on millions of systems. The maintainer went by the name Jia Tan, though it's still unclear whether that identity was real. They built credibility by fixing bugs, responding to issues, and slowly earning trust. By early 2024, they had enough access to ship releases independently. That's when the backdoor was introduced. It was hidden deep inside the build process of 2 new versions, placed where few reviewers would normally look. And while the setup took years, the compromised releases were available for less than 5 weeks before the operation collapsed. The backdoor was discovered before it could be actively exploited. If this backdoor had gone live, here's how the attack chain would have worked. Step 1. Slipping in upstream. The backdoor wasn't added to the public GitHub source where reviewers look. It was embedded in the official release packages instead, meaning even careful source audits wouldn't catch it. Step 2. Planting the payload. When distributions built those packages, hidden build scripts unpacked a pre-compiled object and stitched it into the library. The result? A compromised version of lib.lzma, a core compression library used across Linux systems. Step 3. Setting the hook. The library appeared normal at runtime until OpenSSH verified RSA certificates during an SSH login. At that point, the backdoor intercepted the process and redirected execution into its own code, effectively inserting itself into SSH without modifying OpenSSH itself. Step 4. Pulling the trigger. An attacker could authenticate using a specially crafted certificate containing a hidden command, unlocked only with the attacker's private key. To the server, it looked like a legitimate SSH handshake. In reality, it resulted in remote code execution, often as root. Step 5. Why some distros were more exposed. The risk was the highest on systems where OpenSSH linked against systemd, which in turn linked to lib.lzma. That's why Debian Testing and Fedora were heavily exposed, while others, like NixOS, were less affected by default. Step 6. Almost invisible. The backdoor used obfuscation, which means deliberately making code or data hard to understand, also using environment checks and suppressed logging to stay hidden. And even without a single system being hacked, the fallout was huge. Security researchers called it the most sophisticated supply chain ever attempted against Linux. From the moment the malicious versions were released to when the flaw was discovered and contained was about 5 weeks. But there were no attempts to fix the poisoned code. It was removed entirely. Distributions rolled back to the last known good release, scrapped the compromised builds, and tightened controls around who could ship future updates. The XZ backdoor exposed a harsh truth. Open source runs on trust, and trust alone isn't enough. In response, distributions tightened review processes, added automated checks, and placed far more scrutiny on critical code paths. So why invest years into something this sophisticated only for it never to be used? Most likely because it wasn't ready yet. Slipping the backdoor into XZ was only the first step. Actually using it would have required more time to build infrastructure, select targets, and trigger it without immediately exposing the operation. That moment never came. And then there's Giatan. No one knows who they really were, or if they were real at all. After the backdoor was exposed, the account vanished. In open source, there's no background checks and no identity verifications. Trust is built through code alone, which means the entire persona could have been fabricated from the start. Whether this was a nation-state operation or a lone actor, whoever was behind it is still unknown and potentially already laying the groundwork somewhere else. In the end, this CVE wasn't really about a compression library. It was about trust, how fragile it is, and how close we came to seeing it weaponized against the core of Linux. And that was CVE 2024-3094, one for the archives. And if you enjoyed this, we've got new CVE breakdowns every other week, and longer breakdowns to fall asleep to. Subscribe so you don't miss out. I'll see you in the next one.